channel, and today we're solving this minimum add to make parentheses valid. So if you haven't worked on this question from yesterday, I recommend you to work on the daily question from yesterday, or you can try do it by yourself or watch the video from yesterday. And then now we're trying to expand what this problem is saying, right? So a parenthesis string is valid if and only if it is an empty string, or it can written as like the bracket, right? The opening and the closing are matching. And the only difference between here and yesterday is that you're not guaranteed half of them to be opening parentheses and half of them to be closing parentheses. Here, they're actually no guarantee, and then we want to return the minimum number of moves required to make it valid. All right, let's look at this. So we know from yesterday that something like, hey, this and this, we can like swap it and then makes it become a valid, right? Will become like something like this. But today's problem is actually different. We look at this fourth thing and then like, hey, actually we need to insert probably like opening right here, closing right here, closing right here. So instead we'll return 4, right? So we can still use a stack right here, right? We can still use a stack, right? When we see an opening, we append it into the stack, and then when we see a closing and then we have an opening in the stack, we pop this out, right? So we can still have like if we see an opening, then append, else if there's a stack, then you pop, if stack, then pop, else your count plus equals 1, right? This is exactly what happened from yesterday, right? But instead, right now, at the end, before we return it, we want to also encounter the case where your stack has some empty stuff right there. So let's say this closing, opening example, right? So your stack will first have nothing, because when you encounter this, your count plus 1 and plus 1, right? Now your count is 2. When you see this 2 opening, you actually put it into your stack, right? Okay, now your count is 2. Your stack is have a size of 2, right? So instead of returning just the count, we want to return the count plus the length, the count plus the length of the stack. So this is exactly what we want, and it's totally the same code from yesterday. Besides that, we just want to plus the length of the stack. So let's dive into the code. So from yesterday, we know that we have stack, and then we have a count equals 0. And then for C in S, and then we set if C is the opening bracket, then stack.append it. Else, if stack, we pop it out. Otherwise, we increment the count. And then at the end, we just want to return count plus the length of the stack. So if we run this, and then we submit this, and then you get, please pass. Okay, you get it pass. So the runtime is actually, it's kind of bad, but it's actually just O of n. And the space complexity is also O of n because we're using a stack. So now we can think about how we can actually optimize this, right? I don't think you can optimize any further for the runtime, but how about the space? So what can you do to optimize the space complexity right here? Right. Notice that whenever we see like opening and then we see a closing, we actually just like add it to the stack and then pop it out, right? So what does adding to the stack do for the length of it? It plus 1 to the length of the stack, right? So it plus 1 into the length of the stack. When it pop out, it decrease 1 of the length of the stack. And when we say that, hey, we see there's something in the stack, we definitely want to pop it out, right? And then when we see an opening, we definitely want to put it in, right? So we can just set this to be like open bracket. Like just count for open bracket, right? Whenever you see this open bracket, you increase your open bracket by 1. right? So this is like when you see it and then you just like append it. So it's +1 right here. Then instead of checking if stack, right? We check if open bracket is greater than 0, right? Therefore, you can go in and then minus this open bracket, right? And then at the end, you just want to plus, instead of plus this length of stack, we already keeping track of this open bracket, right? So we just need to put this here. So when we run it, okay, it's still the same. And then we actually just optimize the space complexity right now to be all of 1 because we don't need to use the stack anymore. And I don't know what this was before, but this was kind of bad. I don't know how like Leetcode randomize the runtime, but yeah. So the runtime will still be the same of n, but now we reduce the space complexity down to all of 1. Right. I hope this video is helpful. So I'll see you in the next video.